Hi, you probably learned about trigonometry sometime in your life as a student, whether that's in middle school, high school, or elementary school, or when you're learning it now, maybe. But trigonometry is kind of one of those functions, or not functions, topics that are really essential for you to understand. And basic trigonometry is actually really easy, and it can really put our guard down. It can make us put our guard down if we're not careful enough, because we need to understand the fundamentals really well in order to understand further trigonometry that's integrated into harder topics like differential calculus and integration. So in order to help you, in case you're confused or in case you're looking for something that overarches the entire kind of basics of trigonometry, I'm going to try my best to explain the topic from a student's perspective. So I'm not going to go into all the theoretical proving and explanations that a teacher would give you. I just want to walk you through everything that you need to know as a student myself and just point out the essentials. Okay, so let's start with what trigonometry really is. I'm not going to break down the word and explain to you what each component of the word means. I'm just going to tell you that trigonometry deals with triangles, and a common misconception is that people think that trigonometry deals with right angles only, when in reality, trigonometry really deals with any triangle, and you'll get into the sine rules, cosine rules if you have learned them before. Great. You'll know that trigonometry doesn't only deal with right angle triangles, but the basic trigonometry deals with that. So I'm going to start explaining this first. If you've learned trigonometry before, you probably would have known, you probably would already have heard what SOH-CAH-TOA is. SOH-CAH-TOA, it's a really, catchy, I guess, way of remembering what the sine, cosine, and tangent values are. So when we look at the right angle triangle, there are three lengths basically. In every triangle there's three lengths, but in right angle triangles there's specific lengths that have the same general properties, and the longest length, which is the length that is opposite to the right angle, is going to be called the hypotenuse, and it's basically the longest length within a right angle triangle. And then wherever your angle is situated, the angle that you're dealing with, this is going to be the opposite and this is going to be the adjacent. It's quite easy to remember. One is opposite and one is just right next to it, adjacent. So when we talk about SOH-CAH-TOA, sine, basically you can tell from the letters that sine is going to equal opposite over hypotenuse, cosine is going to equal adjacent over hypotenuse, and tangent is going to equal opposite over adjacent. If you're given values on a right angle triangle, this is exactly how you should solve sine, cosine, and tangent. Okay, so we get into the unit circle now. The unit circle is basically a circle drawn on the Cartesian plane on a y-axis and an x-axis, and it's drawn in a way that the radius is going to be 1 no matter where you draw the line within the circle, right? So it's the value of the radius is going to be 1. And from there, we can make some easy, I guess, calculations. And from this, we can derive actually a couple of fundamental trig identities. So first of all, if we wanted to get the sine of this theta and cosine of this theta, it would be quite simple. We go back to SOH-CAH-TOA and we go sine is equal to opposite over hypotenuse, right? So it would be opposite over 1. And from there, we can tell that anything with 1 in the denominator, it'll just be sine is equal to opposite, and cosine with the same principle is going to equal adjacent. And so what we can derive from this in the unit circle is that sine is going to, so this length, which is essentially the y value, right, is going to equal sine theta. And the same thing, the x value, this is going to equal cosine theta. And so that's what it's dealing with, the unit circle, basically. And from this, we can say that tangent theta is equal to opposite over adjacent, which are sine over cosine, and we get our first kind of really simple trig identity, which is tangent theta is equal to sine theta over cosine theta. And I wrote this here. This is a really, really useful and important one to remember, because in a lot of proving questions, I guess, and in a lot of like complicated questions, it really requires you to change tangent into sine, and in terms of sine and cosine, which makes this really useful. So this one's a really, really, really important one. If you did not hear of this before, and if you don't know what this is, remember this. Tangent is equal to sine theta over cosine theta. If you need a proof, then you can prove through the unit circle. From the unit circle, we can also derive another really common trig identity, which is the sine squared plus cosine squared is equal to 1. And this is basically the Pythagorean theorem, Pythagoras, the something squared plus something squared, the side lengths of a right angle triangle, is equal to the hypotenuse squared, right? Basically the opposite squared, adjacent squared, or vice versa. And so we can prove this because within a triangle, within a right angle triangle, the side lengths are going to be O and A, right? Which are sine and cosine. So it's really simple. Sine squared plus sine squared theta, well, cosine squared theta plus sine squared theta is going to equal the square of the hypotenuse. But since from the unit circle we can tell that the radius, or this hypotenuse, is going to be 1, we can just write that as 1 squared, which is going to be 1. And so that's where we derive this really, really important trig identity. This comes in super duper handy when you have proving questions where you have to kind of change a certain expression into another expression without changing both sides simultaneously. So you'll get those questions later on in the IB, and this identity is really crucial. And from this, we can really derive other things by maneuvering things around, like cosine squared theta is equal to 1 minus sine squared theta. This comes in really handy when you're doing integration, and the opposite can be said: sine squared theta is equal to 1 minus cosine squared theta. Okay, so next up is quadrants, the idea of quadrants. And this might be a little bit confusing to a couple people, so I want to kind of explain it using the unit circle again. So from the unit circle, we can tell that this theta is going to be, let's say theta is 30 degrees, right? So we know that sine 30, basically sine theta, is going to equal opposite, right? Whatever this is. If we draw the same exact angle on the other side of this y-axis, we get this sort of triangle, right? With the same sized angle, sine 30. And we can tell that the lengths of both sides are the exact same, right? And what's really important about this is that when you're given an angle that is supplementary, remember a supplementary angle is, supplementary angles are two angles that add up to 180. So when you're given a supplementary angle of a certain angle, then you can immediately say that it's equal to that value, I guess. Here, let me explain with actual numerical example. So we have sine theta, which is 30, which is equal to O, right? And say you're given to find sine 120. This angle is 120. So you draw on the unit circle a line with the angle 120. And you can kind of redraw this in a way. If you draw this line, you can redraw this so that the triangle, the inside angle, is equal to 30. And that way you've kind of already proven that this triangle and this triangle is going to be the same, so the value is technically going to be the same. So we can say that sine 30 is going to equal, not 120, 150 is going to equal 150. And we can prove it visually through this unit circle. This is going to equal to O, and this is going to equal to O. So obviously that's going to hold true. You can maneuver the unit circle the exact same way on this side and on this side. So just mess around with that. All the values of the x and y of the sine and cosine are going to be the same. The negative and the positive signs is what makes it a little more confusing. And that's where the quadrants come in. And quadrants make it really simple to understand, or simple to remember, I guess. Another mnemonic here, another way of remembering. All students take calculus. So it's a silly mnemonic, but almost everyone that I've met before uses this. All students take calculus, and basically what you can get from this is that the first letters of each word is all students take calculus, ASTC, basically all correspond to the trigonometric function, sine, tangent, and cosine. And this basically means all the functions. So what it's saying is that if it's in this first quadrant, then all sine, cosine, and tangent values are going to be positive. If it's in the second quadrant, the S quadrant, the students, I guess, then only sine is going to be positive, and cosine and tangent are going to be negative. And the same way in the third quadrant, tangent is going to be positive, but sine and cosine are going to be negative, and so on. Same thing for the fourth quadrant, right? Oh, sorry. Same thing for the fourth quadrant. Cosine is going to be positive, but everything else is going to be negative. So basically what you can get from this is if you have, say, if you have the value of cosine 30, right? From what we proved here, we can say that this should technically equal cosine 150, right? But from the quadrants, we can tell if we draw 150, we can tell that it's going to be in the second quadrant. So no matter what, the value of this cosine is going to be a negative, because it says that in the second quadrant, only sine is a positive. So essentially, when you have angles like 30, 150, 180 plus 30 is 210, and 330. If you have angles like this, which are basically, if drawn, all equal to 30 in one way or another. So this is 30, this is 30, this is 30, and this is 30. Then we can say that cosine 30 is going to equal negative cosine 150. Negative cosine 130, right? And cosine 210 is going to equal, again, negative cosine 30. Because only tangent is positive in here. And when we get to the fourth quadrant, cosine, we know that it's positive. So cosine 330 is going to equal positive cosine 30. So that's just a way of using the quadrants as a way to know the signs of each function, I guess. And that pretty much covers the really, really basic trigonometry. And that's all you really need to remember. This one is super important because sometimes you're given to find a certain angle, and people, students, including myself, get this negative and positive sign wrong. So make sure when you're given an angle, make sure to check which quadrant it is in and give the appropriate sign value. So that basically outlines the entirety of what I think basic trigonometry has to offer. Obviously, there's more concepts to trigonometry. This is just the tip of the iceberg, but you really need to understand what unit circles are and how the quadrants work if you really want to continue learning trigonometry effectively. So I hope that helped. If you want me to make more videos on different topics, perhaps you can leave it in the comments below. I do videos on math, physics, and chemistry. I'm a student myself, so it's a great way to review. If you've watched this far, thank you for watching, and I will see you in the next video.